Thank you very much for that warm welcome. Are you enjoying the Science Center today? Yeah? Well, very good, very good. Well, you've got a little bit of time with me now, and what I want to do is I want to introduce you a little bit to the environment of space, specifically in the context of what my career has been dedicated to over the last 25 years plus, and that is the building of the International Space Station. So I'm going to give you a little bit of an introduction into that. We'll talk a little bit about the space shuttle as well. We'll talk a little bit about the Russian Soyuz rocket, and then hopefully, time permitting, we'll have an opportunity to take your questions. And we got a couple of mics set up in the room, so we'll be asking you to go to a mic, and because my favorite part always is the Q&A. So I'll try to be efficient in time and to give us some time for Q&A. This is the vantage point that I'd like to take you to today. This is the Earth. This is what it looks like from the vantage point of the International Space Station. It amazes me throughout my career, and I knew many of the Apollo astronauts as well. Some of them I still are in contact with. It amazes me that everybody that gets off the planet, whether you're going to orbit around the Earth or whether you're going to the moon, your central focus ends up being the Earth again, looking back at the Earth. And I spent a lot of time studying the Earth in the year and a half accumulated time that I was in space. But it's an amazing place that we live, and one that we shouldn't take for granted, and one that we should appreciate all of the things that we have here for life on Earth, for the good of humanity. Again, here's our vantage point. What you see here is the sun's reflection on the ocean and the different cloud formations. Now, where are we looking from? Well, first, we have to get there. And one of the hardest things about space exploration is getting there. And it's also hard to return to Earth. And then there's a few challenges while you're there. My first flight was on the space shuttle. Did anybody by chance here in the room ever get a chance to go see a rocket launch or a space shuttle launch in Florida? It's quite an experience. The space shuttle flew 135 times in total. 47 missions of the space shuttle were dedicated to putting up the International Space Station. My first flight was on the space shuttle Atlantis. This is, of course, what it looked like right after liftoff. On the launch pad, it weighed 4 million pounds, or maybe even a little bit over 4 million pounds. On liftoff, with 3 main engines and 2 solid rocket boosters, it produced 7.5 million pounds of thrust. After 2 minutes after liftoff, the solid rocket boosters did their job and they're jettisoned. So here's in the ascent right here, momentarily we're going to see the solid rocket boosters get jettisoned, and then the space shuttle continue on uphill to orbit. And from liftoff to orbit, it took less than 9 minutes, 8 minutes and 53 seconds. So there's a lot of energy being produced, 3 times the force of gravity. So if I weighed 200 pounds, it felt like 600 pounds as we went up into orbit. And in that 8 minutes and 53 seconds after liftoff, we were going orbital velocity, which is 25,000 kilometers per hour, or 17,500 miles an hour. Orbiting the Earth about 400 kilometers above the Earth. Going that speed, you orbit the Earth every 90 minutes. 1.5 hours it takes to go around the Earth. So we're orbiting the Earth 16 times a day. Okay, I told you I'd tell you about the International Space Station. Has anybody here seen the space station fly overhead? There's a couple of hands. This is your homework assignment I want to leave with the rest of you. There's an opportunity that you have. You can go on the internet, search the internet for a site, or get an app for your smartphone. that will predict for you when the space station will be visible from where you're at here in Singapore. So of course you need a cloudless sky, so you need a clear sky, but you can see it when the space station flies over here right after sunset or right before sunrise. When it's dark here on the surface of the planet, but that 400 kilometers up, the sun is still shining on the space station as it passes over. When you do get an opportunity to see it, it's the brightest thing in the night sky, except for the moon perhaps. But it's brighter than all the stars and brighter than the planets you can see. So I encourage you to do that, take that as a homework assignment. We launched the first 2 elements of the space station, and right here on the bottom is a Russian-built module, and there up in the top in the upper right is a US-built module. They were both launched in the fall of 1998. That's when we started building the space station. And the space shuttle launched with the upper module and then rendezvoused with the other one that had just been launched from Kazakhstan, grabbed it with a robotic arm and put the 2 pieces together, and that began the assembly. This entire assembly right here is on the order of 20 to 25 meters long, to give you an idea of scale. So it's a pretty significant in size, but nothing like the final assembly. It's much smaller than the final assembly. As I said, I think 47 shuttle flights were dedicated to the space station, and many Russian rocket launches as well as we put it together. Again, we started in 1998. We added a module 1 piece at a time over that time. So this was later in fall of 2000. And then we got to this point, we added, these are solar arrays in the upper part of it. So by this time, we got to this point in about 2001 or so. And by this time, we had the first expeditionary crew on board. Fall of 2000 is when Expedition 1 launched. So again, we started building in 1998, first permanent crew 2000. Since then, we've had continuous human presence in orbit. A lot of people aren't aware of that, but going on 22 years now of continuous human presence. The first time that I went to the station was when those 2 modules were there. The second time I went was in this configuration. Only the second time, instead of launching on a space shuttle, I launched on a Russian Soyuz rocket. My first experience was right at the beginning. Second experience on the space station was about halfway through. Those solar arrays that you see up on the top are used to gather the sun's energy and charge batteries, so that we're on the night side of the Earth. Those batteries can discharge and power all of the equipment necessary to operate the space station. By the way, the first module I showed you was right here. So you can see it's already grown in size. And this was less than halfway built at this point. It's very difficult to see, but right down here on the bottom is a Russian Soyuz spacecraft. And that's what we use, at least in part, to get crews to launch off the Earth and get them up to the space station. And then that also serves as our emergency vehicle. If we have an emergency on board, where we can get in there and get back to Earth under emergency conditions. And then after the long stay, the planned stay, which is typically about 6 months at a time, then the crew that arrived on that Soyuz vehicle returns to Earth on that same spacecraft. We continued to build it, so now we're about 2006 or 7. You can see the solar arrays are in a different configuration. We were building it piece by piece. So we have the pressurized modules right here that I showed you in the beginning. And then across here we have a metal large truss structure that's used to house the solar arrays, the batteries, and some of the other external equipment required for the space station. And if you took a piece there, here's another piece here and here. That's the scale of the pieces that came up on the space shuttle. So it gives you an idea. This thing is growing very, very big as we go. So now we get into 2009 or 10 or so. We're adding solar arrays, we're adding modules, adding the truss components, and here we are at final assembly. We've got, each of these are a set of solar arrays, this pair along with that pair, so we got 4 sets of solar arrays. A truss structure that goes across the horizontally here. It's difficult to see on this screen, but the pressurized modules are mostly in this axis right here. In its final configuration after those years of building, we finished it in about 2011. So 1998 to 2011. If you could lay it on the ground, it's much bigger than this room. In fact, it's bigger than a football field. The inside pressurized volume of those modules, it's the equivalent of a 5,000 square foot house. So very roomy inside. And over those years, we went from a crew of 2 to a crew of 3 to a crew of 6, and now we're at a crew of 7. And over those years, we were rotating crew members on the space shuttle, on the Russian Soyuz. In fact, in the entire life of the space station, we've been rotating crews up there and returned to Earth on the Russian Soyuz. And then in the last couple of years, we've added the capability for SpaceX's Dragon vehicles to carry crews up. They carry a crew of 4, the Soyuz carries a crew of 3. That's why we now have a total crew of 7. It is an international space station. Operated and built with the international partnership made up of course, NASA as the integrating partner. Russia is a major partner. Japan is a major partner, and they have a laboratory and some other facilities on board to include a robotic arm. The European Space Agency is a partner. They also have a laboratory, another laboratory module on board. And then Canada is the final partner. Their major contribution was the robotic arm, a very large robotic arm that was used to put this thing together. Typically, when we assembled it, there was a component in the space shuttle. It docked to the space station, and then there was a space shuttle robotic arm that reached in, and we grabbed out the component that we were delivering, put it out into space, and then the robotic arm from the space station, and this is operated by crew members, by astronauts, would come grab this component. It would be released by the space shuttle, and then we would mount it to its final location on the space station and command some latches and bolts or whatever to put them together, and then go outside and do 2 or 3 or sometimes 4 spacewalks to do all of the final integration of that newly arrived component with the rest of the space station. By the way, before I leave this picture, notice in the background the sphere of the Earth. The blue arc there is the atmosphere, that the sun is illuminated from behind, and of course right over here you see the approaching sunset. So it's a beautiful vantage point of the Earth, and you get to see lots of beauty of the Earth. By the way, some people ask me, how did you get this picture? Well, these pictures were typically, and to include this one, were taken by the space shuttle crew after undocking and departing the space station before returning to Earth. I mentioned doing spacewalks. We've done to date, I think it's 230 or 240 or maybe even a few more spacewalks in the life of building the space station. Every time we added a piece, we did, as I said, 2 or 3 or 4 spacewalks. We've also done many other spacewalks to maintain the space station, to fix things when they break on the outside. It is designed to be maintainable. We've got spare parts, spare components that we can change out both inside as well as outside. Doing a spacewalk is perhaps the toughest thing that we do. It's the hardest thing we do both physically and mentally. Physically, because you're in this great big suit that if you weigh, when it's on the ground, it weighs 350 pounds. Of course, we're in a weightless environment, so you're just moving around this big mass in addition to your body weight. That takes a lot of energy from your hands and forearms. So by the time you get back inside after a spacewalk, your arms are just worn out. You're outside for a typical spacewalk about 7 hours. It takes about 6 hours just to get into the suit and wash out the air out of the suit, get back to 100% oxygen, prepare the tools, make sure that there are no leaks in the suit, get into the airlock, and then get out the door. So it's a long day. Starts at 6 in the morning, you're back inside by 7 in the evening. So again, another reason why it's the toughest thing that we get to do. It's also the most rewarding activity that we do in space, in my experience. You can imagine being in the space station, looking out the window and seeing the Earth. But now imagine going outside and you see the entire structure of the space station from outside. You're just hanging on. I'm just attached to a handrail with the little claw that we have that we can attach ourselves, and then seeing the beauty of the Earth in the background. I call it the ultimate skydive. Now, since I've been here in Singapore, we take pictures sometimes with kids, and they always want to do a selfie, right? Even though we have a photographer to take a picture, I wanted to get a selfie. Well, we were doing selfies before the word was invented. Now, let me describe this picture. In the previous picture, you saw the spacesuit, and there's a visor, of course, on the helmet, and the visor is convex in shape, so it distorts a reflection, but it's got a coating on it to protect us from the direct sunlight, and that coating is very reflective. So what you have here in the picture is right in the middle, the black circle is the objective lens of a Nikon camera, just a regular professional grade camera, but it's wrapped in a white thermal blanket because it needs that thermal blanket to protect it from the extreme temperatures out there, which can be several hundred degrees above zero when the sun is shining on certain materials, and it can be 150 or 170 degrees below zero Fahrenheit when it's in the shadows or the night side. So it needs that protection. That's the camera. So it's pointing at the visor. And here on this patch, you see this patch here is one shoulder of the spacesuit, and the flag patch over there, the U.S. flag, is the other shoulder of the spacesuit. And then you have the reflection, and in the reflection you got the entire structure of the space station, and then the globe of the Earth. So it's one of my favorite pictures that bring back the memories of that moment. Here's another unique thing. I talked about studying the Earth and the details of the Earth. There's also some other things that occasionally you see. We knew that there was going to be a supply ship being launched to deliver up about 5,000 pounds or say 2,000 pounds or a little more of kilos of supplies. We knew when it was going to launch. We passed over the launch site in Florida just a little while before the launch time, and then we were looking back behind us. And the sun angle was just good enough where we were able to see the entire ascent of the rocket as it delivered that supply ship into orbit. And it left this trail here, and just a very unique, we're always looking for something new to see, and this was one of those days when we got to see something new. It was also exciting because we knew that rocket was launching a spacecraft that was going to rendezvous with the space station. Then we were going to grab it with a robotic arm, attach it to the berthing port of the space station, and then when we opened the hatches, not only would we have all those supplies that we needed, food, clothing, maybe water, supplies, spare parts, experiments, but the last thing that the crew on the ground was going to put in there was fresh fruit or vegetables. So we knew, in fact, you opened the hatch, and typically the first thing you noticed was the smell of apples or oranges or grapefruit. Sometimes we got onions, sometimes garlic. And all of that was very special because up there, you can imagine, with the food, we don't have refrigeration. So it's very seldom we get fresh food. Let's see here. Okay, I talked a little bit about the Russian Soyuz. Whereas the space shuttle has a crew of 7, the Soyuz has a crew of 3. Whereas the space shuttle weighed about 4.5 million pounds on the launch pad, the Soyuz weighs about 600,000 pounds, or just a little over that. Whereas the total thrust of the space shuttle was 7.5 million pounds, the total thrust at liftoff of the Soyuz is a little less than 1 million pounds of thrust. So it's smaller, but it does its job very well. The space shuttle carried 40,000 pounds of payload and a crew of 7. The Soyuz is designed for a crew of 3 and maybe a few hundred pounds of payload. On the Soyuz, which I flew 3 times, very reliable system that the Russians first flew in the 1960s, 1967, I believe, and they've upgraded it many times, both the rocket and the spacecraft. People ask about it. We're up in the very tip of that, where you see the little white cone-shaped part with the flag on it. You see the Russian flag. That's where the crew is. And we're in the fetal position on our backs, shoulder to shoulder, 3 of us. And I liken it to being triplets in the womb, because that's what it feels like. We launch on a Soyuz and get to orbit in that same roughly little less than 9 minutes, 8 minutes and 58 seconds or so with the Soyuz. Most of the rocket, by the way, is the rocket itself and the fuel that's contained inside. So by the time we get to orbit, only the very upper part, the very tip of it is where we are, goes to orbit. Everything else gets thrown away on the way up. But definitely a highlight of the experience. Return into Earth, I mentioned that. There's the 3 most critical phases of flight. I would say the most risky phases are launch, for obvious reasons, spacewalks, I think for obvious reasons, but also the return to Earth, and it's very dynamic. On the Soyuz, for example, we undock from the space station, separate from the space station, and then flying over, let me give you a little review in geography. We're going 17,500 miles an hour, 25,000 kilometers per hour, till we're going to land in central Kazakhstan. And here we are drifting down under a parachute over central Kazakhstan in Central Asia. We're in an orbit that goes 51.6 degrees north latitude, crosses the equator, 51.6 south latitude, crosses the equator again. So we're coming up to cross the equator on our way to Kazakhstan before the parachute opens. We flying backwards, going at orbital velocity over the southern tip of South America. We fire the engine for just a few minutes and get a change in velocity of only 128 meters per second. And with that small slowing down, then we end up re-entering the atmosphere over the northern tip of, or northern part of Africa, the eastern part of the Mediterranean Sea, across the Middle East, and then end up in Kazakhstan. So that gives you an idea of scale. Now, when we re-enter the atmosphere over, let's say the eastern end of the Mediterranean Sea, when we start going into the atmosphere, that slows us down. The drag builds up, not only the G forces, which build up to a total of 4 Gs, but you also end up in a fireball. And you can look out the window and you see this faint glow. It starts as a faint glow, and over a couple minutes it gets brighter and brighter until it's a bright orange glow, and you realize you're in the middle of a fireball re-entering. After that phase of the re-entry, the fireball starts dissipating, the Gs come down. When you hit about 2 Gs again, then the parachute opening sequence starts. It takes about 25 minutes or so for the parachute opening sequence to complete. And in that time, first the drogue chutes come out, and there's a big explosive bang, and they come out, and because they're attached off-center to the capsule, and the capsule is rotating, you're getting thrown back and forth in your seat in the straps for 10 or 15 seconds. And then automatically that's released, and now you're in free fall again, and then just a second later, there's another explosive force, and the main chute comes out. There's a big opening shock in the main chute, and then gradually you settle down. I can tell you that after 6 months off the planet, that 25 seconds is the longest 25 seconds of your life. You really want the parachute to open. But anyway, you're drifting down. You got about 10 or 12 minutes or so to the surface of the Earth. It's difficult to see here, but this is here's the capsule right here, hanging under the parachute just prior to hitting the ground. About this high off the ground, there are what we call soft landing thrusters. There are 8 of them. They're about this big around, about that long. They're mounted underneath the spacecraft, and they're commanded to fire about 1.5 meters off the ground, and that slows us down just a little bit more. This is what it looks like. And then a second later, it's a very dynamic portion of the mission. It's as if you're going through a car wreck. Not only do you impact the ground and roll around, but you feel this big explosion of the soft landing thrusters going off. But it works very well. It protects the crew from injury, and in all my cases, we had search and rescue forces there with helicopters and all-terrain vehicles and doctors and all the equipment that they would need, and they had us out of the capsule within 30 minutes each time. And then we were on a helicopter going back to a local airfield and then getting on an airplane and heading back to either Russia or to Houston, Texas in the USA. So that's the space station. It's an amazing story. I encourage you to get on the internet and research the history of the space station. Not only the technical achievement of assembling this thing, as I briefly described, but also doing it under the auspices of an international partnership with all of the political challenges that comes on. And then conducting the operation, designing it in the early 90s, initiating the launch of the first component in 1998, finishing it in 2011, and we continue to fly. And we continue to rotate crews. Just within the last 2 months, we rotated both the Russian Soyuz crew as well as SpaceX Dragon crew, and we continue to do that. And then you think about, even with the current events going on in the world, particularly with the war in Ukraine, the difficulties and the challenges of continuing this operation under those conditions. I think the challenges are obvious. I think currently, right now, we are the only positive engagement between the U.S. and Russia. Hopefully there's value in that engagement that's greater than space exploration, and maybe can help us all get along again in the future. With that, I do want to, as I said, leave some time for your questions. So I think we have 2 microphones, one here and one here. I would like to ask you to go to a microphone if you have a question, and we'll see if we have some volunteers for questions. We'll see if we can take them with the time remaining. Who has a question? Encourage you to get up. There it is. Go ahead. So we'll start over here with the young man at the mic. Yeah, it sounds like it's working. It's working.
How does the space toilet work? There's no toilet in space.
Usually I get that as one of the last questions. But you're a brave young man because you were willing to make it the first question. That's an obvious question that comes up. Right here on Earth, we take advantage of gravity, and we have water flow, and everything we want to go away goes away because of water flow and gravity. We don't have that luxury up there. So instead, it's pretty simple, actually. We use airflow. I mean, think about how a vacuum cleaner works. So we just use the airflow and the force of air to control everything we want to control and get everything to go and go hide someplace, right? Now, related to that, though, it brings up a good question, or a related question, and that is, what do you do with all the trash on board, especially the stuff that's smelly? That goes in the containers and it gets sealed up, so that's not a problem, but we still have to store the containers until we can get rid of the trash. But another type of trash that can be challenging is food containers, food packaging. We know if we don't take out the trash from our house every couple of days at least, if not every day, pretty soon the trash starts to really stink because the food starts rotting. So we manage that also. We pack everything into small rubber bags, and they're small because they fill up pretty quickly, and then we can tie them off and seal them, and then we put those inside a bigger rubber bag. We try to compress all the trash as much as possible because we can't just take it outside. We can't throw it out. And then we collect it up usually over weeks or even as much as almost a couple months. And we store it in different parts of the space station until a supply ship has been emptied completely. And then we reload it before we send it away with that trash. And that's one of those big days when you're on orbit when you can clean all the trash out. Suddenly you got a bunch of room left or back again, and you get rid of all that stuff. And it goes into the supply ship, and with all the supply ships that we have, except for the ones that come from SpaceX, burn up in the atmosphere. So it's a very convenient way to throw away trash. Yes, sir.
Hi, yeah. I wanted to ask about your opinions about Elon Musk's plan to colonize Mars and whether you think it will be achievable in our lifetime.
Okay. That's a good question that comes up often. The dream to go to Mars has existed for a long, long time. It was, of course, science fiction in the early 20th century. But even in the early 20th century, the physicists, the mathematicians, the researchers, the theorists determined that, yes, this is possible. We can put people in space. We can send them to the moon. Even Mars is within our reach. So it was fantasized early in science fiction, but then the technology, of course, became a goal in reality as early as the late 50s. We're all familiar with the moon race in the 60s, and most of us are familiar to some extent with what happened since landing on the moon, the development of the space shuttle, space station, ongoing. Now we're talking about going back to the moon. We're developing a program there under the program called Artemis. Artemis in Greek mythology was the sister to Apollo, and that's where the name came from. And that's being done under international partnership as well. But then with the plan to eventually go to Mars. Now, Elon has become famous for his many public comments and tweets, and one of them is, hey, we want to go colonize Mars. Well, and I understand that. It builds up enthusiasm, but my recommendation to you is don't buy a one-way ticket to Mars. One, it's very expensive, and most of us can't afford it. But inherent in the word to colonize a place like that says that you can go and establish a residence there, a habitat and whatnot, and live off the land that's there, which is completely unrealistic. In fact, it's borders on foolishness to accept it that way. We will, I believe, get to Mars eventually. We'll get there in an exploratory fashion. It'll be a small crew. They'll be there for a while, only because it takes a long time to get there, on the order of months. It might take months to come back. But everything you need to live there, and the conditions in which you can live, like Spacecraft, you'll have a habitat. Everything you need to live, the air, the water, the food, and then maintaining all of that has to come from the planet that is habitable, that is Earth. And it'll have to be resupplied from Earth. So don't get fooled into thinking that we can think Earth has a finite lifetime and therefore we can go to Mars and make our new home there. That's a little foolish. Let's see, over here. And I'm going to try to make my answers a little shorter, or we'll only get one or two more. What's your question?
How do you eat when there's no gravity?
How do we eat when there's no gravity? It's a lot of fun, actually. In fact, every astronaut that I have been experienced with likes to play with his food. Just like when you're kids, you get in trouble with your parents because you're playing with your food. because everything will float if you let it. Now, the food that's damp, most of the food it has a dampness to it, right? It sticks to the package that it came in. So it's very easy to just open up a package and spoon it out. Much of the food that we have is dehydrated. We stick a needle in the package and inject hot water in it, let it sit for 10 minutes or so. It rehydrates and then it's ready to eat. But things like M&Ms or other kinds of candy, it's a lot of fun just to kind of throw them at each other. We drink, the drinks that we have, we drink out of a straw. We can't drink out of a cup for obvious reasons. But it can be a lot of fun to eat in space. And like I said, everybody loves to play with their food. Yes, sir? Okay, 3 more questions.
Morning, Jeff. Thanks for your insight into the space station. I just want to find out, with the advent of technology on Earth, the transfer of technology onto the space station, is it viable for long-term leisure space travel because of the Internet of Things and the digital transformation that's going on now? Does it enable self-propelled space travel by leisure travelers?
If I understand your question, it has to do with technology development and application, both in space and back on Earth. One of the primary purposes of the space station is it's a platform. It's there for a long time. We're planning on continuing to fly until at least 2030. Likely, unless with unforeseen circumstances, we'll fly it even beyond that. But one of the primary purposes is because it's a platform that's there for a long period of time, we can use it for technology development. Technology that's designed on the ground and then for application in space can be proven on the space station. We've learned that the initial technology, and for example, life support systems, was inadequate in reliability, inadequate in performance. So we've been upgrading that technology and put it on space station to get more reliable, better performance out of it, so that then we'll be prepared to go for a longer term operation around the moon, eventually onto Mars. So yeah, technology advances. It's advancing for a purpose, and that also has much application on the ground. And we've seen technology advancement just accelerate, right, in recent years.
But will this technology enable leisure travelers to be self-sufficient to make space travel on their own?
I don't think so. Yeah, there's just, as I alluded to earlier, just one category is there's too much dependency on what we have here on Earth just to live. That would have to be resupplied from Earth.
Thank you very much.
Thank you. Yes, sir.
Is there a plan to get to Mars in 50 days using a high-specific impulse inertial confinement fusion engine?
Whoa, you've been studying your science, haven't you? All right. Well, I think one day we will get to Mars. 50 days might be possible if you, as you grow up, and the other people that you work with develop the technology, the propulsion to get us there that quick. Otherwise, it might take just a little bit longer. So that's your job when you grow up, okay?
It's kind of not impossible, but you can do a high delta V burn to get there.
There you go. I'll leave it up to you. Let's take the final question, I think, over here. And apologies to everybody over here. I wish we had more time, but this will be the final one.
Hello. How do you feel about space during just a spacewalk?
What about a spacewalk?
No, your feelings about the space.
Well, spacewalk, as I said, you're outside for about 7 hours. I mentioned it being the hardest thing physically and mentally. It's the highlight of the experience, so.
Can you be a bit more detailed about your personal experience about it?
My personal experience on it, what could I say? Every spacewalk, which is planned 6.5 hours, usually they go a little bit longer, close to 7 hours, is highly choreographed. Every detail is planned in advance. We have special tools to accomplish each of the tasks that are assigned for that particular spacewalk. So we have a ground team on the ground that actually does the development. We have a very large swimming pool in Houston we use to develop each spacewalk and then to train for the spacewalks. On a high fidelity mock-up of the space station, high fidelity tools. And then when you go outside, then of course you've rehearsed it not only in the pool, but rehearsed it mentally over and over and over again. We have the mission control team in Houston that walks us through every steps in case we forget or what's next, or to verify that we've accomplished all of the tasks necessary. And it's all systematic. So if you're putting together anything, it comes in a box and it's complex, you pull out the instructions and you put it together step by step. That's an analog, that's an analogy to what we're doing on spacewalks. It's the hardest thing we do physically and mentally because of those reasons. It's like threading a needle with wearing ski gloves, is a good analogy. Thank you very much for your interest today, and thank you for your great questions.
Thank you. Audience, please